This is lesson 2.1, relations and functions. We're going to analyze relations and functions and use equations of relations and functions. So let's go ahead and first just learn two vocabulary terms, one-to-one function and onto function. So a one-to-one is where each element of the domain is exactly unique excuse me, to one in the range. So there's no repeat outputs. An onto function, each element of the range corresponds to an element of the domain. So notice that we have domain being going to the same range there. We have a repeat in our range, but everything is matched up. Everything from our range is paired up. So when it's both, then everything in the domain is paired to everything in the range, and there's no repeats on either end. Let's talk about discrete. Discrete relation is a relation in which the domain is a set of individual points. Continuous is when the domain of the relation has an infinite number of elements, and the relation can be graphed with a line or smooth curve. So here's an example. Discrete relation, so we've got some points. And then continuous relation when it's going on, and it's that line, infinite forever. So kind of discrete, only specific points, kind of stops there. And then continuous, it continues. Our line continues in both directions forever. We've already talked about the vertical line test, but to talk about that again, some of this stuff is going to repeat from a previous lesson. But it uses the discrete function continuous relations to determine whether it is a function. So if no vertical line intersects a graph in more than one point, the graph represents a function. So if we were to pull this all the way through, and it's only touching at one point all the way through there, that one would be a function. Over here though, going through and we're touching at two different spots. So if a vertical line intersects a graph in two or more points, the graph does not represent a function. Talking about independent versus dependent. Independent are the values that make up the domain, or the x values. So the first things that we're just plugging in, we're just trying these numbers. The dependent, though, are the values that make up the y, our y values, or the range. It's called the dependent variable because it depends on the x. Whatever our x is going to determine what our y value is. So function notation, when an equation represents functions, we use function notation. So for example, if you had something like y equals 5x plus 1 or minus 1, in function notation, what that would look like would be f of x. So we know it's a function of x. So some numbers that we're going to plug in for x. Or f of t, maybe time, so 5 equals 5t minus 1. Or f of negative 2, let's say we were plugging in a specific value, would be 5 times negative 2 minus 1. So before, find y when x equals negative 3. Now, f of negative 3. So what we're doing is plugging this value in for x. It's telling you what's the function solution when we plug in negative 3. So it'd be 5, and then we plug in negative 3 in, minus 1. And then simplify, multiply, and then subtract. All right, let's look at an example. Domain and range, this should be a repeat of section 0. We saw this. Domain is our input, so we would have values 1, 3, 0, negative 4, and negative 3. And then our range, and you could put those in order if you wanted to. would be all of our y values. So 2, 3, -2, -2 again, which I already have, and 1. So is this a function or not? It is a function, yes, because none of our domain numbers repeated. And now we want to determine excuse me, if it is one-to-one onto both or neither. So no domain value is being repeated, but in the range, we had the range having a repeat. So when there's a repeat in the range, then it is considered onto. So it can't be both because we have that repeat in the range. So it is not the one-to-one because our range is repeating. So it's just the onto. And if you need to go back up to your little table here to look at those, you can see that our range being repeated is an onto. Alrighty. Let's look at the graph. So we're going to get our domain and range from the graph points. So all of our x values. So we're just going to list all of our x values, and we can start over here. -2, we have 0 twice, and we have a 1, and we have a 2. So just all of our x's. And then all of our y values, we have a -4 down there, we have a 2, we have a 3, up, and we have a 2 and a 3 again. So, all right, so noticed as we were going that we did have 2 zeros for our x values. That means that our domain was being repeated. So this would not be a function. No, not a function. And again, that vertical line test, if we were to use that, we'll use a red line. Woo, that's big. And we go all the way across, and uh-oh, it's matching up on these 2 points there on the y-axis. So again, not a function. All right, so let's look at this next example. And I do already have mine graphed, but what you're going to do is you're going to put time at the bottom, or years in this case is our time. So 01, 02, 03, every bar. But now for our mileage, you're going to break the graph and start at 20.6 is what I started at there. And then just plotted my points. So if you want to go ahead, if you want to pause, and then you can graph that. And then it's good practice because you are going to be graphing quite a bit. So you really do, it's a good thing to practice. Make sure you're good at. So pause, try graphing, getting your graph to look like mine, and then we can hit play and finish answering the questions. So now that you have it graphed, hopefully, your question is this relation discrete or continuous? So is it just points that are going on, or is there that line that continues to go on forever? And as you can tell, they're just these points. They're not going in a continuous line there. So it is, yes, it is a function. I think that was our first question. None of our repeats. Our vertical line test is good, and it is discrete because of just the points. Discrete. All right, the next one. So this one we're going to go ahead and plug in some points and into our function or equation. So let's go ahead and plug in -2, -1, 0, and 1. So when we plug that in, we just replace the x with the number that we came up with. So -6 minus 1 is -7. So our x value we plugged in was -2. Our output, or our y value, was -7. So that's our coordinate pair. And we repeat that for the rest of them. -3 minus 1 would be -4. So we have an ordered pair of -1, -4. Make sure your x goes first, then your y value. 3 times 0 minus 1 is 2. Oh, nope. That would be 3 times 0 is 0 minus 1, so -1. And 0, -1. And then 3 times 1 minus 1. So 3 minus 1 is 2. to go a little bit slower, make sure we get it right. Okay, so let's go ahead and plot these 4 points. So if we have -2, -7, -1, -4, 0, -1, and 1, 2. And it's going to continue because every value we plug in for x is going to give us that specific output, and it's going to continue on to go in every direction there, because this is an equation for a line. So if we were to write out our domain just of those values that I had up there that are on there, technically our domain is going to be all real numbers, because for any number I plugged in, so if you listed these I'd be fine since those were the specific domain ones, so if you listed all those, but it could be all real numbers. And then if we look at our y value, we're going all directions down and up, so again it could be all real numbers. Or you could list the ones here and that would be fine too. So yes, it is a function. There's nothing being repeated. It is continuous. Remember when it's got the lines, it's a line and goes on forever there. So continuous. And then it is both one-to-one and onto. So each domain value matches up with a unique range value, and they're all paired up. So it's both. All right, go ahead and try these extra examples. Pause, practice those, and then you can come back and hit play or rewind and check your answers. Number 1 is no. You cannot have the x in the denominator spot. A. B is no. You cannot do the square root of x for it to be a linear function. You have to have a slope next to your x, an m and a b. So here's my slope, my m. Here's my b there for begin. So this is a yes, it is a linear function. So it's got to be in that, remember that y equals mx plus b form, where you have your slope and then you have your y-intercept where you're starting. All right, next one is just plugging in. So for that first one, it should be 5/9, and then we plug in our value of 125. Ooh, that's hot. And then we would get 51.7 degrees rounded. Lowest, if you plug that in, you'd wind up with -45. Oops, 0.5. I think that one was repeating too. And so the difference, if you subtracted those, the difference would equal 97.2 repeating degrees. It's from the highest to the lowest. Next, we're going to get that in standard form. So standard form, remember that your A is always with your X, your B is with your Y, and then your C. There, and we want our A to be a positive whole number. So how we undo this is we always just multiply by the denominator. So if we take everything times 3, that's going to keep it balanced, and that's going to get us 2x equals -18y plus 3. And then the way we get our y over there with our x to have a, b, c is just add 18. So it's 2x plus 18y equals 3. So there's our a, there's our b, there's our c. So it's in standard form, a, b, c. X then y equals your c. And then this last one, finding the x and y intercepts, you plug in 0 for the x and solve, then plug in 0 for the y and solve to get your different intercepts. So the first one would be 9 times 0 minus 3y equals 27. And then you would divide by -3 since that's 0. And you get y equals -9. So 0, -9 would be that one intercept. The other intercept, you're going to plug in 0